Machine learning algorithms are categorized into three main categories: supervised, unsupervised, and reinforcement learning. Up till now, we have looked into supervised learning, where in the given data set you have your class label or a target variable present. In unsupervised learning, all you have is set of features. You don't know about your target variable or a class label. Using this data set, we try to identify the underlying structure in that data, or we sometimes try to find the clusters in that data, and we can make useful predictions out of it. K-means is a very popular clustering algorithm, and that's what we are going to look into today. As usual, the tutorial will be in three parts. The first part is theory, then coding, and then exercise. Let's say you have a data set like this where x and y axis represent the two different features, and you want to identify clusters in this data set. Now, when the data set is given to you, you don't have any information on target variables. So you don't know what you're looking for. All you're trying to do is identify some structure into it. And one way of looking into this is these two clusters. Just by visual examination, we can say that this data set has these two clusters. And k-means helps you identify these clusters. Now, k in k-means is a free parameter, wherein before you start the algorithm, you have to tell the algorithm what is the value of k that you are looking for. Here, k is equal to 2. So let's say you have this data set, you start with k is equal to 2, and the first step is to identify two random points which you consider as the center of those two clusters. We call them centroids as well. So you just put two random points here. If your k was, let's say, 3, then you will put 3 random points, okay? And these could be placed anywhere in this 2D place, doesn't matter. Next step is to identify the distance of each of these data points from these centroids. So for example, this data point is more near to this centroid, hence we'll say it belongs to red cluster. Whereas this data point is more near to green, so we'll say this belongs to green cluster. The simple mathematical way to identify the distance is to draw this kind of line, connecting the line between those two centroids, and then draw a perpendicular line. Anything on the left hand side is red cluster, on right hand side is green cluster. So there you go, you already have your two imperfect clunky clusters, and now we try to improve these clusters. Okay, so you already got your two clusters. Now we'll make them better and better at every stage. And the way you do that is you will try to adjust the centroids for these two clusters. For example, for this red cluster, which is these 4 data points, you'll try to find the center of gravity almost, and you'll put the red centroid there, and you do the same thing for green one. So you get this when you make the adjustment. And now you repeat the same process again. Again, you recompute the distance of each of these points from these centroids, and then if the point is more near to red, you put them in a red cluster, otherwise you put it in a green cluster. Okay, so you repeat the same method, and see, now these points got changed from green to red, so they're more near to red, that's why they are in red cluster. And you keep on repeating this process. You just recalculate your centroids, then recalculate the distance of individual data points from these centroids, and readjust the clusters until the point that none of the data points change the cluster. So here right now, see, there is only one green which is changing its cluster, so now it's in red. But after this we are done. Even if you try to recompute everything, none of these data points will change their position, hence we can say that this is final. So these are now my final clusters. Now the most important point here is you need to supply k to your algorithm, but what is a good number on k? Because here we have two-dimensional space. In reality, you will have so many features, and it is hard to visualize that data on a scatter plot. So which k should you start with? Well, there is a technique called elbow method, okay, and we'll look into it. But just to look at our data set, we started with two clusters, but someone might say, oh, no, these are actually 4 clusters. Third person might say, oh, they are actually 6 clusters. So you can see like different people might interpret these things in a different way, and your job is to find out the best possible k number, okay, and that technique is called elbow method. And the way that method works is you start with some k, okay, so let's say we start with k is equal to 2, and we try to compute sum of square error. What it means is for each of the clusters, you try to compute the distance of individual data points from the centroid, you square it, and then you sum it up. So for this cluster, we got sum of square error 1. Similarly, for the second cluster, you will get the error number 2. And you do that for all your cluster, and in the end, you get the total sum of squared errors. Now we do square just to handle negate value. There is nothing more than that, okay? So now we computed SSE for k equal to 2. You repeat the same process for k equal to 3, 4, and so on, okay? And once you have that number, you draw a plot like this. Here I have k going from 1 to 11, and then on the y-axis I have sum of squared error. You'll realize that as you increase number of clusters, it will decrease the error.